Okay, so before I get into this problem, I hope that doing this quote board work stuff is working well for you, that it's helping you practice a bunch, and that you're seeing how to do these integrals a little bit better, and that it feels as close to class as we can get right now. At least you all can go your own pace, and it would be great if we could all be doing this together, but we just can't. So um, uh, let me know how it goes. I think I asked you to do that in the document. But this last one is definitely a bump up, and the directions as they're given here are not really the most clear in the world. It helps to have a picture. So I will show you that picture in just a moment, but I will read you the problem first. Find the mass, so we're integrating a density function of the region within the cylinder. X squared plus y squared is less than 4. So that means that it's a cylinder, a radius 2. And we're looking interior to that, where 0 is less than z is less than y, right? And then we assume that density is a density function of x, y, z equal to just z. So there are a couple things here. I'll just go over to here. If I take y equals z, right? Then that would be this plane right here. If I take z less than y, but bigger than 0, then that would be the space underneath of this plane, but above the xy plane, right? So like this is if I were to look straight down the x-axis in 3D space, I would see a line that's like y equals z or like y equals x, right? Z equals x is what it would be. But it would just be a 45-degree angle plane that doesn't change as we move along the x-axis. Hopefully me saying all that helps you visualize that. So if I come over to here, here's that cylinder, right? X, Y, Z. And then here is that plane slicing that bit. So, excuse me, the region that they're describing with this mess up here is this little wedge of that cylinder, um, uh, and it's got density Z. So hopefully, like, I think that if I was giving you this question, I would tell you all that, but then I would also give this picture to you. I wouldn't expect you to be able to interpret that without a picture. So, given that, here's your spot we're 3 minutes in. Wow. Given that, here's your spot to pause and try it. Okay, now I will scroll down and show you my solution. I got pi. And I'm correct too, I think. Hope so. All right, so let's look at this thing. I'm going to think about the region first. My z. Well, my z starts at the xy plane, which is z equals 0. Then it goes up until it hits this plane right here. Well, that is y. Remember, this is z equals y because things are functions of z. Z equals f of xy. What is f of xy? It's just y. So I go from z equals 0 up to z equals y. That hits the plane. And then I'm going to do that within this cylinder. Notice within that cylinder, my radius is definitely going from 0 to 2 because of that equation right there. And then starting at the x-axis positive side, going around to the positive y and back down. This was the unit circle. It'd be like y-axis, x-axis. I'll be popping from here to there. So I'm only taking theta from 0 to pi. Now when I scroll down here, my mass, triple integral over the region, density, dV. This is the dV, the r, dz, dr, d theta. The density is z, right? And that comes from this right here. And then this one's different from the other ones. One, we're not going 0 to 2 pi, we're going 0 to pi. And then two, and this is why I chose this one, we have r's and thetas in our upper bound right there. So that means that when I do all this stuff, I'm going to get r's and theta. So it's not going to be quite as quick to get through all that integration stuff. So integrate with respect to z. That is 1/2 z squared. This is the first one where I've had something other than just a 1 in there too. So 1/2 z squared. I don't know what happened here. Maybe I wrote the r first. Anyway, 1/2 z squared evaluated from z equals 0 to z equals r sine theta. That gives me, when I square r sine theta, I get a r squared sine theta, but there's another r right here. So I have 1/2 r cubed sine squared theta dr d theta. Next level of integration I'm going to do is the r's. So what do I do? You could do it in either order, actually. But that gives me power rule 1/8 r to the fourth evaluated from 0 to 2. The sine squared theta is just, I moved it out of the way because it's not dependent on r at all. But I left it inside of the outer integral. This evaluates nicely to just a 2. So I get 2 sine squared theta d theta integrated from 0 to pi. Well, I got to use power reduction, double angle formulas to integrate the sine squared. You should be pretty good with that at this point, although it's been a while. This one gets the it's 1 minus cosine 2 theta all over 2, but notice I had a 2 here, so they divide out and just leave me with a 1 minus cosine 2 theta. Got to integrate that from 0 to pi. So I integrate, this goes to theta. This stuff conveniently, I do get a negative 1/2 here, but the sine gets evaluated to 0. The sine of 2 theta gets evaluated to 0 at this 0 bound and at that pi bound. So I just get pi minus 0, and my answer is pi. So, like I said earlier, I hope this is helping. I hope you're feeling good with these integrals. I think we are going to move on to spherical integrals next, which there's like I think the hardest part of spherical integrals is seeing the volume element because it's way more complicated than this. But anyway, we will get there when we get there. You all doing a great job, and thank you, and goodbye.